Good morning. Welcome to Currents Chem World. In this video, let us study complexometric titration. It is also known as EDTA titration. What is the principle of it? How are metal ions hardness of water determined by using EDTA titration? Before we study complexometric titration, it is necessary to know EDTA. It is mainly concerned with the EDTA complex formation reaction. So this is the structure of EDTA. Ethylene, this is ethylene diamine tetraacetic acid. Okay. So it is a multi-dentate ligand or hexadentate ligand. It has 6 coordination sites: 1, 2, 3, 4, 5 and 6. COO minus. Okay. It is the sodium salt of EDTA. Its chemical name is ethylene diamine tetraacetate. It is a white crystalline powder soluble in water. It forms a stable complex with several, almost all the metal ions called chelates and called chelation. It is used also as masking agent. In some cases, metal ions interfere. By adding EDTA to it, it will form stable complex, so the metal ions will not interfere in the process. Metal EDTA complex is generally colorless. This is the structure of octahedral structure of metal chelate complex. Okay, let us now study complexometric titration. It is also known as CHELATOMETRY. It is nothing but a volumetric method where the end point is marked by the formation or removal of a colored complex. At the end point, a colored complex is formed or it is removed. Okay. Now let us take hard water sample in conical flask and add eriochrome black tea indicator, okay, to it. What is used in complexometric titration or EDTA titration? What is the indicator used? Eriochrome black tea. It is blue in color, blue crystals. It is an azo dye. Okay, it is blue. Okay, when you add the indicator to calcium ion, okay, it will form calcium eriochrome black tea complex. This complex is wine red in color. This complex is wine red in color. Okay. Now, on adding EDTA from the burette to conical flask, what will happen? EDTA will form stable complex with the calcium ion. So, this metal calcium eriochrome black tea complex is replaced by metal EDTA complex, which is colorless, and the eriochrome black tea is released, which is blue in color. Okay, at the end point there is a formation of free eriochrome black tea, which results in blue color. Because this replacement reaction occurs because of the stability of metal EDTA complex is much higher than metal indicator complex. So in the previous slide, we have seen the principle of complexometric titration. Now let us see an example how the total hardness in water sample is determined, and also how it is calculated. That is very important. Okay, what is the aim? To estimate the amount of total hardness of a given water sample by EDTA titration using EDTA. What are all required? We need conical flask, burette, pipette and spatula, and also weighing balance. What are the chemicals we need? Buffer, this is very important. We need to maintain for EDTA titration pH equal to 10. Buffer is ammonium hydroxide or ammonium chloride. The indicator eriochrome black tea, it is prepared by 0.5 gram dissolved in 50 ml of spirit, that is rectified spirit or ethanol. EDTA solution 0.01 molar. Okay, now let us see quickly the procedure. Take 20 ml of the given hard water sample in a conical flask, okay, and then add 1 ml of buffer to it. Next, add 2 drops of eriochrome black to it, okay, which turns wine red because of calcium eriochrome black tea complex. Fill the burette with the EDTA. At the end point, on adding EDTA, at the end point, the color changes from wine red to blue, okay, because of the release of free eriochrome black tea. Since calcium EDTA complex is colorless, the release of eriochrome black tea indicator gives blue color. Repeat the titration 3 times to get concordant readings. That means the consequent experiment readings should be same. 3 consequent experiment readings should be same. Okay, now let us see how the total hardness, we have carried out the experiment. Now how the total hardness in the water sample is determined. Okay, now volume of EDTA consumed equal to 5.0 ml. In this case, the volume of EDTA consumed. Volume of sample we have taken in conical flask equal to 25 ml. Okay, so moles of EDTA, we know number of moles of EDTA equal to M1 into V1. Okay, M1 into V1 gives moles of EDTA reacted with the sample. 0.01 mole, okay, EDTA, we know the concentration moles per liter into 5 milliliter, therefore into liter into 10 power 3, okay, milli means 10 power 3 liter. Therefore moles of EDTA equal to 5.0 into 10 power 5 moles. According to law of volumetric analysis, N1 V1 equal to N2 V2 or M1 V1 equal to M2 V2. That means number of moles of EDTA equal to number of moles of calcium ion. Okay, number of moles of calcium. Therefore, number of moles of calcium Ca2 plus ion, Mg2 plus ion in the sample is equal to number of moles of EDTA. So, the total hardness is the sum of concentrations of calcium ion and magnesium ions present in the sample. This is the total hardness, therefore equal to 5 into 10 power 5 moles. Now, moles of calcium carbonate, okay, the total hardness is expressed in calcium carbonate, okay, mass of calcium carbonate, that is in milligram per liter. Okay, now moles of calcium carbonate is equal to this much. Okay, that is number of moles of EDTA equal to number of moles of calcium carbonate. So N equal to mass by molecular weight, we know this. Therefore molecular mass of calcium carbonate equal to 100 gram per mole. Okay, so mass of calcium carbonate equal to n into molecular mass. So n 5 into 10 power 5 mole into 100 into 10 power 3. Why do we put 10 power 3? Milligram, because the total hardness is expressed calcium carbonate mass milligram per liter. Therefore, into 10 power 3 milligram per mole equal to 5.0. Okay, on cancelling 5.0 milligram. Okay, 25 ml of, now please careful, 25 ml of the sample contains 5.0 milligram of calcium carbonate. Therefore 1000 ml, that is total hardness. 1000 ml consists of 5.0 divided by 25 into 1000, that is 200 milligram per liter. Okay, so this is a hard water. Below 75 milligram per liter is soft water. Above, in this range, above 75, it is hot water. Okay, thank you for watching. Please share and subscribe. Thank you again.